everybody, and welcome back to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood, and this week I'm talking to Jean-Georges Perrin. I hope I got that somewhat close. I don't speak a lot of French, just a little bit of French. But anyway, we're going to be talking about Spark. Do you want to introduce yourself real quick? Let us know who you are, why you're famous, all that stuff.
Yeah, first of all, thanks for having me, Charles. I don't think I'm famous. I just happen to have written a book about Spark, but that doesn't make me famous, does it?
You're on a podcast now. You're famous.
Oh, okay. So that's making my day now. Yeah, I've got to ask everybody to call me sir when I leave the room.
Are you making more than $100,000 per year and just realized that you topped out the pay scale at your current company? And you still want to make more money working on interesting projects for companies that'll pay you more? Or maybe there's just some freedom level that money will give you. Well, let me help. I'm starting a program to help developers move up in their careers using proven techniques and by starting a podcast in order to advance. Right now, I'm only scheduling calls to see where you're at, where you want to go, and how you can get there. There's no sales pitch. You can schedule the call at devchat.tv/nextlevel.
So, as my accent is a bit of a treason for me, I'm French, but I now live in the US, in North Carolina, where life is not unpleasant, maybe if it's a little bit cold today for us, which is probably, for most people, it's not cold.
Yeah. Well, I think it just depends on where you grew up and where you live, how used to it you are.
Yeah, Southerners say that you get your blood that is getting thinner. So that's a thing. So.
Yeah, something like that. Anyway, well, we brought you on to talk about Spark because you're the author of Spark in Action for Manning. And I have to admit, I've talked to a few people about Spark. I have a really, really vague idea what it does because I haven't done it in a while. I haven't talked to anybody about it in a while. And this is a machine learning show. So I'm hoping that you can kind of tie the two together as far as what Spark does and how it can play into what we do with machine learning.
Yeah, of course. So I like to define Spark, and I'm borrowing the definition from a friend of mine, Rob Thomas from IBM. I like to use his definition of Spark as an analytics operating system, and one of the common definition you will hear is also a framework, okay, for data processing. Why I extend that to an operating system is it's because when you're building applications, and whether it's applications that leverage models or just data processing, they need an environment to run on, okay? And as as Zoom right now is using my Mac as the operating system for, leveraging communication and the interface to my microphone and all this thing, it's exactly the same thing with Spark. It's creating this abstraction layer on top of the hardware, and especially on distributed systems, and provides functions such as analytical functions that you can leverage in data processing, and which includes machine learning. So,
gotcha.
So that's how I like to see Spark, and as it's along the way of what we've seen in the last 20 years, where to scale processing, you're not scaling a single machine like we used to do, but we're focusing on clusters, we're focusing on distributed processing, and that's where Spark is giving us a great advantage on whatever we want to do. Is it's abstracting us from dealing with, hey, I've got this node which is gone kaput, okay, and I've got to replace the hard drive. It's not the business of your application, and especially when you're talking to data scientists who barely knows what a disk drive is.
True.
So you've got to provide them the tools and the environment for them to develop and exploit their creativity, and that, for me, that's what Spark is.
I gotcha. So kind of taking this to the next level then, as far as machine learning goes, I can imagine then that we do a lot of, or we rely on a lot of data scientists to do the data cleanup, the data management, the making it so that it will go neatly into our algorithms so that we can train the machine, or we can, get the result out that we want, or things like that. And so Spark's kind of the precursor to what we're doing. Or does it have a machine learning engine in it?
So it does. Okay. So that's part of, I was kind of describing Spark as distributed computing layer, but as part of the libraries and the tool set that it's bringing, the framework that it's bringing to users, is a lot of functions, and those functions are split, I would say, in 4 categories. You've got SQL, okay, so that's your data engineer kind of dreamland, where you can use all the SQL statement you like. You've got graph, so you can have graph-oriented databases, and you can have machine learning through the MLlib, which is already including some of the basic stuff like linear regression, logarithmic regressions, and all these tools, and it includes some of neural networks algorithm as well. But it's the great thing about it. It's that it's easily opens to more. Okay, so see it as this interface to a larger world. So for example, I was playing the other day with XGB Boost, and I'm not a data scientist, and so, but I managed to compile it and add it to Spark pretty easily, and all the tools I was familiar with, all the APIs I was familiar with, I could just leverage them like right out of the box. Okay, so basically, the only thing I had to learn was the intricacies of this specific model processor that I was trying. So that's where Spark is great. Okay, you learn one API, which is a data frame API. And so it changed a little bit from, right now Spark is version 3. And in the very early version of Spark, people were talking about RDD, the resilient distributed datasets, which still exist. But the data frame is now the new API that is highly efficient for dealing with that. A bit like the Python data frame API. And that, once you've learned that, you get accustomed, and then you just plug in whatever you want underneath. Okay, so it's great for data engineering. Okay, so I like to call myself a little bit of a data engineer, more than a data scientist, definitely more than a data scientist. And so ingesting this data, cleaning the data, eventually pushing the data out to external systems, that's Spark is great. And at some point, when you've got data of quality you like, well, then plug in your data scientist at this point. Okay, so it's easy also to distribute the job, so you don't have to ask a data scientist to do data engineering, and vice versa.
Gotcha. So what do these APIs look like, and what languages can you write them in?
So Spark is written in Scala.
And that's cool. I've always wanted to learn Scala.
Well, that's actually something I would not recommend.
It just looks like an interesting language to me. That's all.
Yeah, I'm not saying you can have this intellectual curiosity, which is great, but the thing is, and that's also where you can continue the analogy with the operating system part, is when you develop an application and operating system, okay, you can use many languages, and Spark is in the same way. So it was written in Scala, but it doesn't mean that it's because it was written in Scala that you need to learn Scala to use it. Okay, you can you can use Java, you can use Python, you can use R. So you've got these 4 languages which you can leverage. And Microsoft is actually also working on, if I'm not mistaken, a .NET interface with F#. It's really
okay. So there are some approachable languages that you can hit this with.
Yeah, and Python's definitely in the data science world. Python is the most popular, and they fully support Python 3. Python 2 is out of the door anyway. They kicked it out finally, so it's all good. And most, if not all, data scientists I know are using what they call PySpark, which is Python for Spark.
Right. Yeah, that makes sense. So you get Python in there. What kinds of things are you going to do from there? I mean, how much programming are you? Let me back up. So let's say that I have a big pile of data, right? I've gathered a whole bunch of information about, something that I'm interested in managing the data around. So I've got all this data sitting there and I need it cleaned up, right? How do I go about actually putting that together with Spark, right? Am I writing programs and loading them into Spark? Or am I just pushing it at Spark and giving it some cursory, hey, run this algorithm that you already know? Or how does that work?
Well, yeah, it's a bit like that. Okay, so Spark is ingesting the data. It's not like it's not going to do some kind of data federation. Okay, so it's not like, hey, I've got this data in an Oracle database and I've got this data in a CSV file and it's going to stay there. Spark is actually going to physically move the data in its core, and which relies on memory. Okay, Spark is heavy in memory and heavy on smart and utilizing the memory. So it doesn't mean that when you compare it to Hadoop, some people try to compare Spark to Hadoop. Hadoop is very disk intensive. Spark is very memory intensive. Okay, so let's say you've got this data, they're coming from different sources. You know that when you want to start finding interesting stuff in your data, it's not just one data source. It could be one data source, but it's usually when you try to join them all. Okay, and Spark doesn't care at all whether you're going to have data that is coming from CSV files, JSON, Parquet, or
APIs.
Relational database. It's not that great for APIs, but the thing is you can extend your data sources. Okay, so let's say you want to call specific systems, like, I don't know, like let's say Google Analytics, and you just want to make single calls with it, and then you can use APIs in this situation. Okay, but you've got to write the interface, or you've got to find someone that wrote the interface for you. But it's really anything JDBC, anything files or custom things. There's all these ways of bringing the data in the Spark. That's the ingestion part. Okay, so and if I plug it for the book, this is so important that I've covered 4 chapters out of the 17 we have in the book just on ingestion. Okay, so it's not that it's difficult; is that there's a lot of ways to do it, and it mainly depends on every data source you have. So then you've got the data in Spark, and then you can do your transformation. You can start doing your transformations using the data frame API or SQL. Okay, but basically SQL is mapped to the data frame API. And then you just natively start your transformation. And the way Spark does it is really smart. As you do your transformation, Spark does nothing. Okay, so you just wait on. I like the analogy of teens. Okay, my wife and we've got a few teens here.
Got a couple here too.
Okay, and so they are. You ask them something, and it doesn't happen. You ask them something again and again and again, and it doesn't happen. And at some point, you start raising your voice or threatening a little bit, and then magically things happen. So Spark is a bit like this teenager. Okay, you can ask him, "Hey, modify this column."
My kids. Wow.
So you start asking Spark, hey, modify this data. Yeah, whatever. Just ask again, and you keep asking, and at some point you run an action, and that's when the teen is waking up. I say, oh, okay. And it looks at all the actions you've been doing because it put that in a DAG, in a directed acyclic graph. Okay, and it looks at this, which is kind of a data transformation recipe, and it looks at the various different steps and say, okay, I can optimize this thing, and I'll do it for you. I'll do the optimization for you, and the optimization is done via an optimizer, and which is called Catalyst in the context of Spark, and it optimizes the work, and it creates the different tasks that are going to be spread on the different nodes of your cluster. So this is a completely transparent operation for you, and it's really super efficient. Okay, because they don't do the data one step at a step as you do it, but they, like you would do in a SQL in a SQL database. Okay, in a traditional relational database, you ask for something to be done, then it does it, and if you don't like it, or if there was a potential optimization, well, too bad for you. Okay, so Spark is really clever in that way.
Yep, awesome. Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium. So then it kind of sounds like Spark manages its own storage.
Correct.
Right. So as you ingest all this data in, it stores it however it stores it. And then when you need the data or the result or whatever you're looking for out of it, you just query it. right?
So it's not storing the data in the sense that it's a database, okay?
Right, right.
Um, so I would say that the data is kind of transient in your data processing approach, okay?
Okay,
So you ingest all the data, you clean it up, and then
right.
at some point, you also decide to eventually apply some machine learning to do some advanced transformation on the
Uh-huh.
data. And then you decide to export it to somewhere, okay?
Okay, that's what I
Okay.
was wondering.
Yeah. So your data can be, you can export it to, let's say, Tableau, or you can export it to a Parquet file, and then this Parquet file is used somewhere, or you can, that's how you could use it. Okay.
Right.
Over the time, there's two major companies behind Spark. Well, more, but originally there were two major companies behind Spark. One was Databricks, where
Uh-huh.
with the founders of Sparkware, and another company was IBM, kind of a little
Right.
startup from the north in
Yeah, I've
New
heard of
York.
them.
Yeah.
Yeah.
And but it's interesting because it's not a well-known fact. Okay, they're kind of, it's ridiculous. They're a bit shy about that. But anyway, so they contribute as well, and they, for example, the Catalyst in Spark version 2, the optimizer comes from IBM Labs. Okay, so
Uh-huh.
there's this brilliant community of engineers that built this, and they created this mechanism for this flow of data. And when I mean flow, it also applies to streaming.
Right.
So you can have streaming in Spark, or you can have batch processing. Okay, so both are going there, and it doesn't compete. That's one of the beauty of the thing. We're thinking about, streaming, is it competing with Kafka or something? It doesn't compete with Kafka. Kafka can feed Spark, okay, so as Pulsar, and the data that is being brought out of Spark can also be pushed out via the same means. So
Oh,
it's really
nice.
rich, as it's kind of this in place systems that you can use for your data transformation in your data pipeline. So yeah.
That's awesome. So I'm a little curious as we kind of get into this. I mean, I love stories, right? I love hearing, okay, we had this problem and we solved it this way, or there's this really interesting group that did this really interesting thing with it. Can you give us some examples of people using Spark, or maybe where you've used it in your work
Yeah.
to solve some problems?
So I'm an enterprise architect for also a small company called Advanced Auto Parts, and we sell auto parts. And our data science team is using Spark to do all this sales prediction, to do this procurement prediction. So there's a lot of operations we do with Spark.
Uh-huh.
Okay, so we get from this data, from our sales data, from our historical sales data. That's a combination. That's a great team we have, which is a team which is comprised of data engineers and data scientists, and they work, in a current single group, where they take the data from our data lake and apply all this very scientific methods to extract insights, and then the
Uh-huh.
insights are redispatched through the company. So that's one way we use Spark, and we have quite a few clusters that are being used for that part. Okay, so that's a very traditional way of using Spark. Other things that I've touched was a very interesting usage we had in one of my previous lives, was to aggregate data from, we had a SQL server, a mega size SQL server that we could not really touch anymore because it was so big, and it would be too expensive in licenses to multiply, etc. So,
Right.
and we wanted to start doing some analytics on that, and there were two problems. The thing is, the schema has evolved over time. Okay, and that's a problem with relational database, and you were
Right.
kind of sticking to the original schema, and we need to get the data from the SQL server, clean it, well, not really clean it, more like rearrange it in a certain way, and then store it somewhere, and then give the users the ability to also query the data. Okay, so what we did is we used Spark to get the data from the SQL server, like a very simple
Right.
ingestion, not a lot of data sources, just a one data source, this SQL server. We put this data in Elasticsearch, and we created this almost this canonical models where we reformatted the data in some way, but that's the only transformation we did. And then we developed another interface, which was also Spark based, where data scientists, data engineers, and even application developers could query the data, not directly through SQL, through Elasticsearch, but via a dedicated interface that was being run on Spark. So you had your reference trusted data in Elasticsearch, but as you were going to consume it, Spark would create snapshots of this data in different environments based on what you needed and the format you needed. So creating, and this snapshot would, you could call the data mart as well. Okay. So data scientists, they want the data in a specific way. Say just, hey, I want these data sets in this way, under this shape, with this in a columnar way. Okay, no problem. Okay, and our service would just go that, transform the data through Spark, and make it available. So that's the kind of thing you can do. Another interesting project. It was kind of a fun project. It's not in production, but it was about gathering data from multiple sources, creating using NLU and specifically NLG, natural language generation.
Right.
From the data we gathered, and through the distributed processing, we would ask each node to publish the result of the data. So it means that, we've got this ginormous data set. Let's start looking at every item we want to generate something from, and we create this content and broadcast it via the Spark workers, and that would scale like crazy as well. Okay, so you can, you're creating these atomic operations on your data, which are being done by the worker, and then you can do whatever you want. So
very cool.
There's a lot of use cases and a lot of things that you can do with Spark. And I kind of like the idea that it's kind of, when you learn the API or with SQL, it's becoming a bit the lingua franca that can be used between the data engineers and the data scientists.
Nice. So what's coming next for Spark?
So Spark is in its version 3 since June, roughly. And that's when we published the book. And what I think they've reached a maturity level. Spark is 10 years old, so it's not like it's this startup project that came out 6 months ago. Okay, so it's pretty mature now, and you can see that the release cycle is still good, but it's not like it's not as dynamic as I think as it used to be. So it's really a very mature product. But what the community is working around is more and more developing the ecosystem around it. And one of the very exciting products that Databricks is pushing is a database called Delta Lake. And Delta sits very close to Spark. Okay, one of the issue of getting data in and out from Spark is you've got to transfer it. Okay, there's no magic. Okay, so the thing is, if it sits in your Oracle database, you've got to initiate your JDBC connection, blah blah blah,
right?
Get the data, bring it back. Okay, so there's network latencies, there's access, there's writes, there's all these things. When you have a database which sits very close to the core of Spark, like what's the goal of Delta Lake, you can dump it there. Okay, and you can start to have transactions there as well, and you can create your reference, you can, that's one way to create your, I was using my air quotes, the data lake using Delta Lake. Okay, and I think that's a very interesting concept. What Databricks is trying to push is a concept of what they call the lake house, which is an hybrid between the data warehouse and the data lake. Okay, so you could say that the data warehouse is probably a little bit too structured, and you need months and months of preparation before you see any results, like a bit of a waterfall approach. When you look at the data lake, it's a bit of too easy, and people just dump things like in a data swamp. Okay, and it starts to rot after some time. The lake house is trying to fit in this middle ground, and I think that's where Spark is, not Spark itself, but Spark as part of this ecosystem is going. So it's a very interesting venue.
Very cool.
Yeah, and it's more, I would say it's more towards data engineering than data science, but it's bringing the tools and the environment that the data scientists need. Okay, so I think that's really great. One of the tools that they also added to this ecosystem, and I'm spacing out the name now, is some kind of a report / BI tool for business users. Okay, so simplifying some operations, so you don't need you want this report, so you don't need to leverage a 150K data scientists to do this.
Right.
So that's also an approach that they're taking. So widening the outcome, I would say, of Spark.
Very cool.
Yeah, it is. It is a very cool domain. And you think that, you could imagine that, hey, everything has been done in this domain, but no, really not. So yeah.
Cool. Very cool.
Yeah. Other avenues. If you, it's also like, we're building clusters, so that's kind of almost a system engineers. So a lot of people were building Spark clusters using, if you go to the cloud like Amazon, you would use EC2 instances, and you would have big instances, and you create your cluster in the cloud. But as much as it would scale, you would rely on auto provisioning, on auto deprovisioning from Amazon, and that might not be the right way you want to do it, or not as flexible as you want. So one big thing that is also going more and more mature was introduced in Spark 2.2 or 2.3. It's the support for Kubernetes, and it's now really getting more and more mature. That means that if you want to think scalability, you can use Spark very easily on either Kubernetes or OpenShift. And I think this is a very interesting trend as well. Not really for the data scientists, except that they don't have to provision super big clusters. They can, provision normal size Kubernetes-based clusters, and they don't have to worry too much about getting their finger slapped because they use $50,000 in a week of clusters.
Wow, that's awesome.
Yeah, so
I love the way that some of these things just kind of come together and solve problems.
Yeah, and I think this is part of this growing ecosystem around, and that's why, going back to the beginning, it's an operating system, okay, on top of everything.
Very cool. Well, do you want to just kind of give us the 5-minute pitch for your book?
Okay, I can do that. I try to stick under the 5 minutes. It's a big book. It's 600 pages. And the only thing to remember is that, and I'm not quoting, it's not me, I'm just quoting one of the reader. It's the best book on Spark. And it's actually backed up by figures. If you go to Amazon and you look for Spark book, it's the only one with a 4.8 or higher rating.
Oh, nice.
Yeah, it's 4.8 on the US website, and I don't know, maybe I paid some French people, but on the Amazon French website, it's 4.9, and it's not even translated in French. So for French people to rate an English book that high, I don't know, they were probably high. but anyway, no. The thing is, a lot of the books, and I've got a lot of respect for a lot of the writers that some of. Yeah, I know some of them personally. The approach was a bit different. I'm an engineer, even if I'm an architect now. But the thing is, I'm an engineer at heart. Okay, so I've been doing development. I had the problems of engineering, and that's the axis I took for writing the book. So if you're a data scientist, you will learn a lot of things about data engineering. And you will learn a lot of things about Spark. But it's not a book targeted purely for data scientists, and it's also data engineers are often, the fact that Spark was written in Scala was a bit of a trouble for a lot of people, and because, okay, I want to use Spark, but do I have to learn Scala? Okay, and the thing is, if you answer yes to this question, then it means you're raising the bar, and you're not helping people that wants to access this book or start reading this book. Okay, so you're creating an artificial barrier to Spark, and that's also, so as a data engineer, I was more like a still more of a Java person and
Uh-huh.
not ashamed of it. So I decided to write all of the examples in Java, which is still the most popular language when you come to developing applications at an enterprise level. But we also have all the examples in Python, okay? So and in
Uh-huh.
Scala. So when you approach the book, you will be able to read it from the angle of whatever your favorite language is.
Right.
So we didn't do R, but we've got Python, Scala, and Java. So that's also one of the approaches, that it's not this. A lot of the books I found were very Scala oriented, which is creating this barrier. And another thing is, I mentioned quickly Hadoop before. A lot of people were seeing Spark as an evolution of Hadoop and assume that you knew Hadoop before you start learning Spark. And
Right.
that's also something I wanted to avoid, that I didn't want to say, hey, learn HDFS, Yarn, and all those things.
Yeah.
And then come to Spark. Okay. So that's what it assumes, that you're a software engineer, okay, Java or Python or eventually Scala, and you want to learn about big data, and a little bit about data processing already.
Right.
Well, that's a book for you. Okay, so you don't have to. The barrier is you don't have a PhD in machine learning to start reading the book.
I like that. I like that a lot because, yeah, I'll admit, I mean, I know some Java, but for the most part, my experience has been with Ruby and JavaScript. And yeah, I pick books based on the languages that I know best,
It makes
right?
sense. Yeah.
And yeah, because I want to learn whatever's in the book, and I don't want to have to go learn the language in order to learn whatever's in the book. So yeah, I'll pick the JavaScript book because that's usually the most common language for, that people will use that I know. And then if I can't find it, then I'll go to the Java or the Python or something that I feel comfortable approaching, even if I'm not an expert in it. And
Yeah.
so, yeah, I really like that approach.
And finally, I also try to have, it's a Spark in action. Okay, it's a Manning in action book. Okay, so it's not about full of theories and boring stuff. It's about getting to the core, getting shit done.
Yeah.
And
Oh yeah.
yeah. And the thing is, if I used this kind of, you've got column A, column B, column C, and your values are 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, this is not teaching you anything. This is BS. And a lot of examples you find, I would say, are this kind of let's assume this perfect scenario and work with it. Well, none of my examples are perfect scenarios. They are real data sets. I had a lot of fun actually going on to open data websites and data.gov when it was running well, and all the on gathering all these complex real life data sets that you need to work on. Okay, your life is not about the perfect scenario. So use your shitty data, go figure it out. Okay, and that's what the book is also using. So
I don't know. I mean, all of my data is ABC 1, 2, 3, and let me tell you how useful my algorithms are because of that. Yeah, that makes sense. I love it. All right. Well, you can get the book on Manning.com. The way Manning does it, and I'll just let people know, if you want the ebook, you have to get it from Manning. If you want the print book, you can usually go find that on Amazon. And Manning gave me a coupon code. I think it's for 35% off. Let me just double check that. 35% off. It's all their stuff, not just this book. And that's Pod ML Adventure 20. And I'll put that in the show notes so you don't have to remember it because it's kind of long. But yeah, so if you want to go pick up this book and maybe check out some of the other courses or some of the other authors that we've had on this show, that's the way to go, because you get 35% off.
Manning is really great about that. The fact you don't have to buy. If you buy the print one, for some reason I'm still attached to print. Maybe it's kind of a bit traitor to my age.
No, I like it too. I mean, there's just something about holding the book.
Yeah, and especially when you've got this thing. Hey, it cost me a fortune to send to my parents back in France. It was probably even cheaper to buy it on Amazon in France. But I wanted a signed copy.
There you go.
But hey, free Christmas gifts. But nevertheless, yeah, one great thing about mining is when you buy the print version, you get the PDF as well. Okay, so you go back and I'm saying that because there was a lot of illustration in the book. They are all in color, but mining is printing paper on paper in black and white. So if you want a nice color illustration, you need a PDF. So just plug for the PDF.
Good deal. Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit, and you can find that at summit.mostvaluable.dev. Well, let's go ahead and do some picks. Now, on this show, we do picks. It's just stuff we like that we've been enjoying, things like that. I'm trying to think exactly where I want to go with this. I did pick this on Adventures in DevOps earlier this week, but there's been a lot of unrest here in the US. I'm not sure if this is going out next week or next month. I think it's next month. So this may all be moot by then, but I doubt it. But the thing is that a lot of people are really angry. And I'm not saying that you shouldn't be, but what I am saying is that I've seen a lot of people that I know are good folks yell at other people that I also know are good folks because they don't agree on this stuff. And I really just want to call out, and we see this in the tech community too, by the way, about other stuff, right? And I just want to call out just basically, hey, look, take a minute, see the humanity in the people that you don't agree with. Talk to somebody who you don't agree with and try and understand where they're coming from. Not argue your point, not try and be right, just understand where they're coming from. And then just see where we end up. Because honestly, I don't see a way that we come out of this without actually doing that. The other alternative is basically violence, and I think we can avoid it. So anyway, I'm just going to call that out. And hopefully people can just take a step back, take a breath, and then try and understand somebody that's not you. The other thing that I'm going to pick, and I think I might have picked this on a previous show, but I've been really enjoying it. I'm going to pick two shows. They're both on Amazon Prime. One of them's an older show. It was on Sci-Fi Channel, right? So they just picked up all the seasons on Amazon Prime. It's called Eureka. It is such a funny show. And basically, it's this town where all these geniuses live and work on top secret projects for a company that caters to the government. In fact, the head of them actually reports to DOD, right? So it's a DOD division. But anyway, it's really funny. It's this sheriff, right, who's just an average Joe. And he's the one that solves all their problems because he doesn't get so sucked into all the stupid details, and the whiz-bang ways of solving things, right? It's like, oh, well, he kind of deduces his way to the answer and then goes, oh, and then he gives them a common sense solution. So I really enjoy that show. And then the other one is The Expanse, and that's in season 5. They're releasing one episode per week, which I just want to binge it. Amazon, binge. This is the key word, binge. Just give me all of them. Anyway, really enjoying that. The books are terrific. The TV show sticks fairly close to the books. They've deviated some, but for the most part, they've stuck pretty darn close to it. And so I really enjoyed the books, and I've really enjoyed the TV show. And funny enough, the discrepancies between the two haven't bothered me. Usually it does in movies and TV shows. This hasn't. So anyway, I'm going to pick that, The Expanse. And yeah, do you have some things you want to shout out about?
I will completely second you and on your choices. Eureka, I found out about Eureka, and it's amazing in simplicity, I would say, in some cases. It's like I love the role of the sheriff. I don't remember. I'm really bad at remembering actors' names, but I completely agree with that. And really, I think, yeah, it's time to, the trolling has to stop now. I moved to the US. Nobody forced me. I didn't have a gun on part of my head and say, "Oh, you've got to move to the US." I decided to move to the US because of this American dream kind of way, this different way of life, this tolerance for each other. And I think that we have been really bad lately at that thing, and we need to reintegrate that into our values. And my green card is coming to 5 years in February, so I can apply for citizenship. So,
great.
Yeah, so I want to be part of this in this reconciliation process we really need to do. And I've got friends on both sides, and let's be friends again.
Yeah, I have friends on both sides. I'm pretty entrenched on one side, I'll admit. And the other thing is that it's usually within tech, I'm entrenched on the other side. But I really want to understand where people are coming from. And I think there is a path forward to just discussing and understanding and, at least having a shared vision for why this is a great country. So anyway. All right. Well, if people want to follow you on social media or stuff, where do they find you?
Well, I'm on Twitter, of course. My account is still running. I didn't put any controversies there. At least sometimes a debate between Scala and Java, but that's not offending more people than that, and it's not risking anyone's life, so it's still okay. So that's JG Perrin, and I'm on Facebook, but that's merely like this place where it's to go to have fun and not be serious at all, and that's also facebook.com/JG Perrin, and I'm on LinkedIn. On LinkedIn, if you want to contact with me on to connect with me on LinkedIn, I welcome that. I love that because it's honestly more serious discussions usually, but I don't take anyone. Since I've become an enterprise architect at Advanced Auto Parts, it's incredible the number of spam I'm getting now. So just tell you heard the podcast, or you read the book, or you're interested in the book, or you like Spark, or just don't try to sell me something. and then we can connect and get richer together. So intellectually.
All right, sounds good,
Charles. Thank you very
thanks.
much.
This has been awesome. Yeah. All right. Well, now I have another thing I want to go play with.
Hey, you've got a friends in business now, okay? So just ask questions. I'm happy to help you.
Sounds good. All right, folks. Till next time, max out.
Bye-bye. Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.